Hi students, in this video we're going to look at how to antiderive the 1 over x function. Right, so after this video you should be able to establish and use the rule for anti-differentiating the 1 over x function, and we're going to use that again with adding some functions together and anti-differentiating that, and also anything that also has something complex in brackets. We'll do some of those examples too. All right, so big things to remember. Once again, anti-differentiation is the opposite or inverse of deriving. Don't forget our constant of integration when we integrate functions. And also, don't forget the derivative of our natural log function. So as we've already covered, the derivative of natural log is 1 over x. And that will become important when we start doing the anti-differentiating, the inverse of that. Right, so if we've got the function of ln x, we know that the derivative of natural log x is 1 over x. So that means when we go in reverse, all we're basically saying then is that when we integrate 1 on x dx, as soon as we see a reciprocal 1 over x, something like that, we immediately think natural log, and what's on the bottom becomes the subject of that log. So 1 over x becomes 1 natural log x plus c. And that's our simple rule that we're going to use. So if we've got our function here, a over x, then our anti-derivative of that function, dx, will just become a times natural log of x plus c, a constant of integration. Now, if we have our something a bit more complex in the denominator, then when we anti-differentiate that, that'll be 1 over bx minus d dx. Now, to start off with, our 1 over function rule, or our 1 on x rule, says it will become a natural log, whatever's on the bottom, bx minus d. But if we were using our chain rule, we would multiply by the derivative of what's in brackets. In this case, once again, we are going to divide by the derivative of what's in brackets, and then have a plus c there on the end. So when we're integrating or anti-differentiating our 1 over functions, it becomes natural log of whatever's in the denominator, and then divide by the derivative of what's in the denominator. So a couple of quick examples. We've got our function here that's 4 over x plus e to the negative 2x, so our exponential part here. Our integral will be 4 over x plus e to the negative 2x dx, which equals, all right, so the integral or the antiderivative of 4 over x, well, that's 4 over natural log x plus, now the antiderivative of e to the negative 2 on x, well, that's an exponential, so it stays the same, but divide by the derivative of what's in the power, negative 2. So when simplified, that will be 4 natural log x minus 2e to the negative 2x plus c. Sorry, that should be half, not 2. Half plus c. All right, and then in this second example, we've got our integral of 2 over 3x plus 5 dx is going to equal 2 natural log, what's in the denominator? 3x plus 5. And then divided by the derivative of what's in brackets there. Derivative of that is 3 plus c. That can't be simplified, so that's a fine solution there, ready to go. Now, students, one quick note on that. This only works when what's in the denominator is a linear function. Okay, it has to be linear. If we have something like 4 over x squared, that's a power function that we can integrate using our regular power rule of adding 1 to the power and dividing by the new power. So that one works okay, but if it's just 1 over x, or x has a power of 1 in the denominator, then we use our natural log rule, not if there's a squared or anything else in there. Alright, so after watching this video, students, you should be able to use the anti-differentiate 1 over x functions.